HVAC temp rise formula to measure airflow cubic feet per minute, explained step by step with exact math, expert tuning tips for accurate combustion and airflow diagnostics, and what to do with sensor holes after testing to prevent air leakage and restore ductwork integrity. Start with the basic HVAC temp rise formula. Airflow in cubic feet per minute equals furnace output in British thermal units per hour divided by 1.08 times temperature rise in degrees Fahrenheit, written as CFM equals BTU, H, divided by 1.08 times delta T, where 1.08 is the product of air density, specific heat, and minutes per hour. Measure output British thermal units per hour from the rating plate, then adjust if the high fire input is clocked lower or higher than nameplate by multiplying by measured input to output efficiency, not the rated efficiency. Take temperature rise with a fast response thermistor or Type K thermocouple 10 feet downstream of the heat exchanger and 3 feet upstream of the return plenum, away from radiant surfaces, averaging across the airflow with at least 5 points per plane. Stabilize the system for 15 minutes on the selected heat stage and set the blower to the correct tap or percent, because taking readings during ramp or after a recent defrost will skew delta temperature. Correct for supply air humidity only when coil is wet in heating with heat pump reheat. Otherwise, ignore latent terms because the formula assumes sensible heat. If you have a two-stage or modulating furnace, measure on each steady state stage and record separate airflow cubic feet per minute, then align blower tables to keep temperature rise inside the manufacturer's window. Cross-check the calculated airflow cubic feet per minute against external static pressure and the blower performance table. If the math says 1,100 cubic feet per minute, but the table at measured total external static pressure shows 800 cubic feet per minute, your measurements or assumptions are off. After testing, restore the duct by sealing any sensor penetrations so the calculated airflow cubic feet per minute still matches what the blower actually delivers in a tight system. One of the biggest mistakes in HVAC airflow testing is using the input British thermal units per hour instead of output British thermal units per hour in the temperature rise formula, which causes inflated airflow cubic feet per minute results. Fix it by multiplying measured input by steady state efficiency or using the rated output when combustion testing is not performed. Another common error in airflow diagnostics is taking supply and return temperatures too close to heat sources or leaks, causing false high or low temperature rise. Fix it by drilling test ports on straight duct runs at least 10 duct diameters from transitions and averaging multiple insertion points. The third frequent issue in heating airflow measurement is forgetting to plug sensor holes, which creates duct leakage, depressurizes rooms, and corrupts future temperature and static pressure readings. Fix it by sealing holes right after testing, using metal screws and approved mastic or foil tape over a metal patch to fully restore ductwork and improve indoor air quality and energy efficiency. BigHomeProjects.com lists verified heating and cooling pros who follow proper testing methods for airflow cubic feet per minute, temperature rise, and duct sealing, so homeowners get accurate diagnostics instead of guesswork. Contractors use BigHomeProjects.com to showcase credentials, win local jobs, and connect with customers who value airtight ductwork, professional test ports, and correct sensor hole repair with sheet metal zip screws and sealant.